Today we're going to talk about how to calculate the surface area of prisms. A prism is any sort of polyhedron that has two congruent parallel faces or bases. In other words, it has two opposite sides that are parallel to each other, like the top of this prism and the bottom of this prism, that are congruent. See how these are equal sized rectangles. That makes this a prism, two equal congruent sides that are parallel and opposite of each other. Now, in the prism category, there's really two types of prisms. There's right prisms, where the lateral is a fancy word for sides, really. So the three sides around this prism that aren't the top and bottom bases, those are lateral edges, those lines of those. So if those lateral edges, like this one here, are all altitudes, they're all making right angles to the base here, that makes it a right prism. Oblique prisms essentially are leaning prisms. The lateral sides, so these four rectangles around each side, they're not really rectangles anymore. They're parallelograms because they're leaning. They're not going straight up at right angles. That makes it an oblique prism. There's two ways to find the surface area of prisms. The long way is what I'll show you first, and that's by literally drawing out a net and calculating the area of every single face or side of your whole prism before adding it up. So for example, on this prism for number 1, we can draw out our net and label the sides. And then because each side is a rectangle, we could use area equals base times height to find all the areas. 5 times 10 is 50, 4 times 10 is 40, 5 times 4 is 20, and so on. Add it all up and you get that the surface area total is 220 square centimeters. That is how much area there are on all the surfaces of the outside of your shape added up. I like to think of surface area as how much wrapping paper it would take to cover the outside of a shape. So, drawing a net and finding the area of each rectangle or other type shape that covers a face of the net is a longer way to solve. There is a shorter way, and that's what you'll practice most today. Copy down these steps. The other way to find the surface area of a prism is to use the surface area equals P times H plus 2B equation. To set up that equation, you first need to find the area of the base, the perimeter of the base, the height of the prism, and then plug that all in. So here's my base. It has sides of 6 and 3 centimeters. So its area is going to be base times height. 6 times 3 is 18. So capital B stands for area of the base, so I'd say capital B equals 18. Try to avoid using lowercase b for that because that doesn't usually mean the whole area of a base. Lowercase b usually means an edge length instead. And then I could find perimeter of the same base. If I add up all four sides, 6 plus 3, 6 plus 3, I get perimeter is 18. So I take those ingredients as well as the height of the prism, 4 centimeters here, and I plug that all in to surface area equals pH plus 2b. And I get that the surface area of my shape is 108 square centimeters. So now you know how that process works. I next want to show you why it works. So go back to the question above. Number 1, we're going to walk through how this surface area equals pH plus 2b works. Really what that surface area equation is doing is it is splitting your net not into 6 different rectangles, but into 3 different rectangles. We have here, when we combine these sides, one giant rectangle, and the height of the rectangle is the same as the height of the prism. The base of the rectangle, though, see how it's 5 plus 4 plus 5 plus 4 to get the whole base of the rectangle? That's equivalent to the perimeter of the base rectangle of your prism, 5 plus 4 plus 5 plus 4. So the base of this rectangle is perimeter of the prism. Here's the height of the prism. So base times height would be 18 times 10, which would get me 180 square centimeters for this rectangle. That's not the whole rectangle though, because there's that top and bottom base pair. They're going to match, however, in area. So if this one's 20, that one's 20. So I could do perimeter times height plus 2 base areas and get the surface area that way. So that is the logic behind the formula. You get the same answer, but it's a lot faster. We're going to practice using the surface area formula to find surface area on the back page. So go ahead and do question 2 on your own. Pause the video here, and then begin the video again when you're finished. So for question 2, you find the area of the base. It's a rectangle, so you do base times height, and you get 12. Perimeter of the base, you add up the sides, and you get 14. You plug that in. Perimeter times height would be, perimeter is 14, height of the whole prism was 6, and then 2 bases. You get 108 square feet. Go ahead and try number 3. Pause the video and restart when you're done. You should get 64 square inches for number 3. Now, number 4 gets a little bit different because for number 4, we have a triangular prism. So I want you to notice that this time, the rectangle side here doesn't really count as a base side because there's no top side parallel to it. So the only 2 sides that are equal and parallel are the triangle sides here and here. So you could think of this as a prism on its side. The base is actually this triangle. And the height of the prism, if it was standing upright, would be this 12 centimeters here. So with that tip, go ahead and solve number 4. Pause the video and restart when you're done. This time, to find the area of your base, it's a triangle, so you have to use a triangle area formula. 1/2 base times height. So you multiply the base and height and divide by 2. The area of the triangle base is 12. Perimeter of the triangle, when you add up the sides, 5 plus 5 plus 8 is 18. You take that and you plug it in. Or don't forget that this prism is on its side, so this 12 is the height of the prism. You could think of h in ph plus 2b as really just the distance between your 2 bases. Number 5 is very similar to number 4. There's just one difficulty. Finding the area of the base isn't that bad. You're still doing 1/2 base times height to get area of a triangle. And because it's a right triangle, you could say that the side is the height. However, when you try to find the perimeter, you'll notice you're missing one side. Oh no! Luckily, you have a method from chapter 8 that helps you solve for missing sides of right triangles when you already know 2 sides. Pythagorean theorem. Now you have your perimeter as well as your base area, and now you could plug it all in. Pause the video here and try questions 6 and 7 on your own. Restart the video to check your answers when you're done. Here's the work for number 6. It's another right triangle, so you do 1/2 base times height, where the height is the side. And you get 6.3 for the base area. Perimeter, you're missing a side, so you use Pythagorean theorem to solve. That will help you finish up perimeter. And then you plug it all in. Number 7. This one's the trickiest so far, because at first, you don't have the height of the triangle. It might be a right triangle, but you don't know, so you can't assume that you could use this as base and height. You actually have to calculate the height. Luckily, it's an isosceles triangle, so you could assume that if you drew a height, if you drew an altitude, it would cut the base in equal halves. So this little half triangle would have a base of 3. So now you can imagine a little right triangle with sides of 3, 5 would be the C, and 3 and X would be the A and B. You can get that the missing height of the triangle, X here, would be 4. And now you could calculate area of the base. Take that and perimeter. Notice how this prism is on its side. So if you think of the height of the prism as the distance between the matching bases, the height would be 12. Then you'd plug it all in. So at this point, you've seen prisms with rectangular bases, prisms with triangular bases, but there's actually a lot more different types of prisms. because the bases of the prisms can be any type of polygon. They just have to match each other. So you'll also see a lot of prisms where the bases are matching polygons with more than 3 sides or 4 sides. Here we have a hexagonal prism because the bases, this side and this side that are parallel and equal, have 6 sides. So then when you zoom in on that base, because it's a regular polygon, you're using area equals 1/2 AP. So you plug in the aposem, you plug in the perimeter, and you get the area of that base. All the sides match, so there's 6 sides that are 6 meters each, should be 36 for the perimeter. Plug that all in. The height of the whole prism, since this prism is on its side, is 12. That seems to be a running pattern here. And you should get around 619.2 square centimeters. Great job, everybody.